Hey, it's Josh. In our last video, we explored IP addresses and figured out what exactly they are and how they enable devices to communicate. But that was just the beginning. Did you know that the structure of an IP address, how it's assigned, and how networks are divided into subnets all play a critical role in making the internet work smoothly? Let's break it down. Today, we're diving deeper into IP addresses, meaning how they're structured, the difference between dynamic and static IPs, and how subnets keep networks organized. First, let's discuss the structure of IP addresses. Most IP addresses you've seen have probably looked like this. This is an IPv4 address, IPv4 being Internet Protocol version 4. And it's made up of four numbers called octets, and these are separated by periods. Think of each octet as part of an address. You have the city, the street, the building, and the apartment number. Together, they pinpoint exactly where a device is on a network. Next, we have range. Each number in an octet can range from 0 to 255. Ultimately, this gives IPv4 a total of about 4.3 billion unique addresses. I'd like to also mention there's also IPv6 or Internet Protocol version 6, which looks much longer, and it's designed to provide more addresses, mainly because the internet continues to grow. But for now, we're going to focus on IPv4. It's still widely used. Next, let's discuss static versus dynamic IP addresses. Dynamic IP addresses are like parking spaces. They're assigned to your device when you connect to the network, but once you leave, they're free for someone else to use. This type of assignment is common in home networks or public Wi-Fi or really any environment where devices frequently connect and disconnect. Static IP addresses, on the other hand, are like assigned parking spaces. They're reserved for a specific device and they don't change over time. Typically, these are used for things like servers, printers, and other devices that need to be consistently reachable, and they often use static IP addresses. So with that said, that poses the question, why does it really matter? Dynamic IP addresses are exceptionally useful because they can efficiently use a limited pool of IP addresses amongst devices in a network. Remember, there's only so many IPv4 addresses that are possible. Each and every day, we continue to have more and more devices accessing the internet. And for that reason, every single device needs an IP address, and we only have a limited amount. And so when we have so many devices, such as phones that need internet access but don't require the same IP address every day, dynamic IP addresses are exceptionally useful. On the other hand, static IP addresses are again critical when devices have to be accessible. Many configurations are hardwired for specific IP addresses, meaning if those addresses change and a device tries to access a certain resource that is configured with a static IP address, it's no longer accessible. For example, your home printer may be accessible at the IP address 10.10.10.20, but if the IP address of that printer changes, you can no longer reach that printer and essentially can't print anything. That is until you reconfigure the IP address within the configuration. Other use cases include web hosting or remote access and network devices like routers and firewalls that often rely on static IPs to ensure consistent communication. Next, let's talk subnets. What is a subnet? A subnet or subnetwork is a way of dividing a larger network into smaller, more manageable pieces. Overall, this improves communication and efficiency and security by preventing unnecessary interference and congestion. So let's break this down. Imagine 1,000 people gathered in a single gymnasium, and they're all talking at the same time. Each person may be having their own conversation with another. The noise and interruptions from everyone talking makes it really hard to communicate clearly. In the same sense, messages might be misheard or drowned out entirely. Now, imagine splitting those same 1,000 people into smaller groups, each being assigned to its own gymnasium. Suddenly, conversations become clearer because fewer people are sharing the same space, and the risk of interruptions is greatly reduced. This is kind of how subnets work. They divide a large network into smaller segments, and they make communication more efficient and overall more organized. Now, let's put this in a more practical scenario. Let's reimagine a business network with 200 devices. These devices have IP addresses falling within the range of 192.168.1.1 all the way to 192.168.1.200. Managing all these devices in a single network can quickly become chaotic. So we're going to create 5 subnetworks to better organize them based on commonality and their function. Let's look at a subnet breakdown here. Number one, we're going to have end user devices, which would include laptops and desktops. These are what people are using day to day. We want to put these into an IP range of 192.168.1.1 all the way to 192.168.1.50. This should accommodate all end user devices. And as I mentioned, this subnet is going to be reserved for employee laptops and desktops, and it's going to ensure these devices can communicate efficiently without interfering with other types of network traffic or communication. For the second subnet, we're going to have servers, and these are going to be hosting internal websites and applications utilized by the company. This IP range is going to be 192.168.1.51 all the way to 192.168.1.100. Again, this should easily accommodate all of these servers that this company has and probably leave additional room for growth. And again, this subnet is going to be dedicated to servers, and this is going to help isolate high traffic services like internal websites or applications, because these are going to commonly probably be used by the end user devices such as laptops and desktops. And depending on if these websites are accessible by the internet, we could expect a lot more traffic. So we want to give them ample room to be able to communicate. For the third subnet, we're going to have company phones. They may use a voice over IP. This IP range is going to be 192.168.1.101 all the way to 192.168.1.130. And the intent of this subnet is actually super important. And this is going to isolate these devices to ensure clear and uninterrupted voice communication, because voice communication is definitely a little bit more sensitive, and we want to ensure that it's by itself and again has its own room or its own subnetwork. For the fourth subnet, we're going to have printers, scanners, and faxes. This range is going to start to close in just like the voice over IP system range. This one's going to be 192.168.1.131 all the way to 192.168.1.160. This subnet is grouped for streamlined communication without impacting other parts of the network. And you can kind of see how these are like devices, right? Things that print, things that scan, and things that fax. And these would be kind of considered peripheral devices. And then lastly, our fifth subnet is going to be for network infrastructure. This IP range is 192.168.1.161 all the way to 192.168.1.200. And this is actually one of the most critical subnets because this is going to be reserved for critical infrastructure like switches, routers, and security appliances. These are all the devices that make your network operate as well as protect it. So this is very, very important. And so again, this is just a simple example of breaking down a smaller company network into manageable subnets. This not only isolates these devices among commonality and their function, but also provides a layer of security where communication is separated. And so with that example, I want to emphasize on why subnets matter. By organizing devices into subnets, the business reduces congestion and improves communication efficiency. Each subnet isolates traffic within its group, preventing interference from other parts of the network. As an added bonus, this also improves security. Problems in one subnet, like a compromised device, is not going to affect devices in other parts of the network. So pulling this all together, today we explored the structure of IP addresses. We also covered the differences between static and dynamic IP addresses. And we also discussed how subnets keep networks efficient and organized. Above all, these concepts are foundational for understanding how a network operates. In the next video, we're going to dive deeper into public and private IP addresses. We'll discover what they mean, how they work, and why are they so important for security and scalability.